Hello dear students, in today's class we will learn the theorems of moment of inertia. So there are two theorems, theorem of parallel axis and theorem of perpendicular axis, that actually relates the moment of inertia of the body about one particular axis with some other standard axis. First let us learn the theorem of parallel axis. The statement goes like this. According to this theorem, the moment of inertia of a body about any axis is equal to the sum of the moment of inertia about a parallel axis through its center of mass and the product of the mass of the body and the square of the distance between the two axes. So let us visualize this principle. So suppose you have a rigid body and suppose here is the center of mass of this rigid body. Consider an axis that is passing through the center of mass. There can be plenty of axes that passes through the center of mass that lies in different directions. Suppose you want to find the moment of inertia of this body about an arbitrary axis given by this green line AB. Since this axis is arbitrary, that is, it is situated at some random point inside the body, we do not know the moment of inertia about this particular axis AB. To find the moment of inertia about this axis AB, you can use the moment of inertia, this theorem of parallel axis. For that, you will have to find a parallel axis to this AB that is passing through the center of mass. Here in this figure, this red dotted line represents the parallel axis that is passing through the center of mass, which is this dot here. So these two are parallel axes. AB is the arbitrary axis about which the moment of inertia of the body has to be found out. CD is the parallel axis passing through the center of mass. Now, according to this theorem of parallel axis, we have moment of inertia about AB. It is equal to moment of inertia of the body about an axis passing through the center of mass, which is parallel to the first axis, plus the total mass of the body into the distance between the axis square. Here the distance between the axes is given by E, the perpendicular distance. Since they are parallel, the distance will be same anywhere inside the body. So this is the theorem of parallel axis. If you want to find the moment of inertia of the body about an arbitrary axis, find a parallel axis that passes through the center of mass. This will be usually a standard expression, plus mass of the body into the square of the distance between them. So simply you can find the moment of inertia of the body about any axis using this principle. ICM, as I have said, is usually a standard equation. MA square can be simply found out. So if you change the axis to any other random place inside the body, you can easily find out the moment of inertia of the body about that random axis if you know the moment of inertia ICM. So one more point that you need to remember, moment of inertia of a body is not a constant for all the axes. For about one particular axis, moment of inertia will be a constant. But if you take another axis, the moment of inertia will have a different value because I is equal to summation mr square. So depending on the choice of the axis, the moment of inertia will be different. So I hope you understood the concept of theorem of parallel axis. This can be applied in a lot of situations to find out the moment of inertia about the tangent of the sphere or moment of inertia about tangent of a disk or any arbitrary body. Now let us derive or prove this theorem of parallel axis. Consider a body like this. Suppose you want to find the moment of inertia about AB. AB is at a distance of A from the standard axis about which the moment of inertia we know. But we are rotating the body about this AB. Now the total moment of inertia of this whole body is the sum of moment of inertia of each individual particle inside this body, right? So one particular point has to be found, has to be selected inside the body. Its moment of inertia has to be calculated, and sum of all the points inside the body has to be taken to find the total moment of inertia. So what is the moment of inertia of this particular point about the axis AB? Suppose the mass of this particular point is given by small m. What is the distance from the small m towards the axis AB? Distance is a plus x. So the moment of inertia of this particular point will be m into a plus x the whole square. So if you choose any random point inside this body, its distance towards the axis AB can be represented as this constant a plus x. What is x? You have to note that x is the distance from the point for which we are finding the moment of inertia towards the axis passing through center of mass. And a is the distance from the axis passing through the center of mass towards the axis about which we are finding the moment of inertia. So in this way, we can represent the moment of inertia of all the particles inside this body. And hence, I can write the total moment of inertia I is equal to summation over the moment of inertia of all the particles. So take each individual particle, find its moment of inertia, express it as mass into a plus x the whole square. Take the sum, you will get the total moment of inertia I. Now let me just modify this equation. So we have I is equal to summation mass into x plus a the whole square. So if you open the brackets, it will be summation mass into x square plus a square plus 2ax. So this is simply summation mx square plus a square into summation m. I can take a square outside this summation since a square is a constant, but summation mx square, both m and x have variables. Depending on the choice of the point, m and x will vary. So you cannot take m or x outside the summation. Here a square is a constant irrespective of the choice of the point, plus 2a mx summation. So 2 and a are constants there into summation mx. Now let us see what each of these terms means. What is summation mx square? X is the distance of the point from the axis passing through the center of mass. So from here, this axis passing through the center of mass, the distance towards any point is denoted as x. So what will be summation mx square? It is nothing but the moment of inertia of the body about the axis passing through center of mass. Summation mx square is ICM itself. Now a square into summation over m. What is summation over m? If you sum over the total individual masses of all the particles, what you will be getting is the total mass of the body. Summation over m means the total mass of the body multiplied by a square. And finally, the last term, 2a into summation over mx. Summation over mx actually represents the sum of the moments of the particles. It is actually 0. If the body is balancing or not breaking, this means that the sum of the moments of the particle is 0. So this term is 0. So I can write final expression as I is equal to, I is the moment of inertia of the body about this axis AB. It is equal to moment of inertia of the body about the center of mass, axis passing through the center of mass, plus mass into a square. So this is the parallel axis theorem. So we have proved parallel axis theorem by assuming the basic concepts. We splitted the total distance from the axis to the point as a plus x, and that is how we proceed. So I hope you understood the concept. Try to visualize this. ICM can also be different depending on the direction of the axis. We will see all those examples in the coming classes. Now moving to the second theorem of theorems on moment of inertia. Second theorem is theorem of perpendicular axis. So what is this theorem? The theorem states that the moment of inertia of a plane lamina about an axis perpendicular to its plane is equal to the sum of moments of inertia of the lamina about two axes at right angles to each other in its own plane and intersecting each other at the point where the perpendicular axis passes through it. So let us visualize this particular theorem. So suppose you have a planar lamina like this. So the important point that you have to note is that the theorems on perpendicular axis applies only for planar laminas, plane bodies. And now you want to find the moment of inertia of this body about a perpendicular axis which is perpendicular to its plane and passing through any arbitrary point. So this red axis is actually perpendicular to the plane of the body. Now to find that, all you need to know is the moment of inertia of this body about an axis lying on the plane and another axis which is also lying on the same plane, and these must be perpendicular. Suppose this first line represents the moment of inertia of the body about the x direction. Second represents the moment of inertia of the body about y direction. Clearly, the body is lying in the xy plane. X and y are axes inside this body. Now to find the moment of inertia of the body about the z axis, which is Iz, all you need to take is to sum Ix and Iy. So the important concepts are Iz is the moment of inertia of the body about a perpendicular axis to its plane. Ix and Iy are both moment of inertia about the body about axis lying on its plane, but Ix and Iy should be perpendicular to each other. So this is the statement and visualization of theorem of perpendicular axis. Now let us try to prove theorem of perpendicular axis. So consider a planar lamina like this. So z axis is coming out from this plane. Now we are rotating this body about this z axis like this. It is rotating like this. Now to find the moment of inertia of the total body, we need to consider individual particles. So let us consider this one particle here. It is at a distance of r from the axis, z axis. Now let us consider two different axes. One is y and x. X and y both lies on the plane of this body. Now if I rotate this body about x axis, the moment of inertia will be Ix. What will be the moment of inertia of this one particle if I rotate it about x axis? It will be rotating like this about x axis. For that, we need to know the mass of the particle, which is simply m, and the distance from the particle towards this axis, let it be y. Then I can write Ix is equal to my square. For the single particle, if you are rotating it about the x-axis, it is my square. Y is the perpendicular distance from the x-axis towards this particle. Since there are a lot of particles inside the body, total Ix will be summation my square. So we will consider each individual particle inside the body and take the sum. Now similarly, what will be Iy? If you are rotating the body about the y-axis, this point will be executing circular motion about the y-axis. In that case, the moment of inertia will be mass into x square. X is the perpendicular distance from this axis towards this particular particle. So I can write Iy is equal to mx square. Now we are considering all the particles inside the body and take the sum to find the total moment of inertia. So this is Iy and Ix, and what we want to find is Iz. Similarly, Iz is simply summation over mr square, right? Because here from the z-axis, r is the distance towards this arbitrary point m. But from the geometry of the figure, you can see that r square is x square plus y square. Since this is x, this parallel line is also x. The base is x. The height is y. And what is this hypotenuse? It will be related as r square is equal to x square plus y square. So this can be expressed as Iz is equal to summation over m into x square plus y square, which is equal to summation mx square. Opening the brackets, we get summation mx square plus summation my square, which is nothing but Ix plus Iy. So we have proved perpendicular axis theorem. Z is a perpendicular axis to this plane, is equal to Ix plus Iy. X and y both lies in this plane. But for this theorem to hold, x and y should be perpendicular to each other. Both x, y and z are in fact perpendicular to each other and passes through the same point. Then only these equations will hold and this theorem will work. I hope the concept of this theorem is clear for you. Try to think about this and try to visualize it and draw figures about it. I hope all the theorems that we have discussed is clear for you and you are able to do problems related to this. Thank you.